Okay, now I'm recording. Okay, so we got to finish this little part right here. This was our graphing calculator. So we had to graph these equations and then we had to tell domain and range. So you guys still have your graphing calculators out? Okay, go ahead and get them back out or just watch with me. I'm going to graph them, I think. Let me find it. We should know enough that we maybe don't even need to graph it. We should kind of know what the transformations are without it. I think I already heard a reciprocal graph, which is always good. So I've got 1 over x, 1 divided by x plus 3. Now this is where you kind of have to know your calculator. I grew up with an older calculator, so I have parentheses all the time on a lot of things to keep everything straight. But if you don't need them, then don't use them. That's totally fine. I'm going to graph it. And again, you should just be in a very standard window that should see everything. And again, just because I knew it is, it looks reciprocal. However, there's something funny going on that graph. What do you guys notice? Asymptote. Where's that asymptote at? 3. Good. And if you didn't know, you can figure that out based on the equation, or you can go to your graph and try and figure out where does it change from approaching, etc. But that's at 3. So if we do our domain here, I still have that vertical asymptote still at 0. So my vertical asymptote is going to be what? Or sorry, not vertical asymptote. What's my domain going to be? Negative infinity to positive. Oh, negative infinity to 0. And then 0 to positive infinity. Okay, good. Sorry, let's see if my brain will stay with us for the last few minutes. And then range is almost the exact same thing, but what's the piece that's missing on the range? You already told me what the horizontal asymptote was. What is it? 3. Good. So we'll do negative infinity to 3 and then positive infinity to 3, or positive 3 to infinity. Cool. All right, next set. It's an absolute value. You kind of graphed one of those by hand basically a minute ago. But if not, how do I go about putting the absolute value in my calculator? Do you guys remember how to do that? Math. Arrow over. And then I'll do x minus 4.
We don't have to have the starting point. We have to have like actual points on the graph.
What are you talking about?
Like we have to put like multiple points on the graph on our quiz.
Have I put multiple points on any of these? But do you know, can you see what I'm doing? You can't do like a V shape that's like this and call it, like it has to be close enough.
Yeah.
I've taught math for longer than some of you have been, or I've at least taken math since longer than some of you have been alive. So I don't need points. But if you think that you need points to make sure you're going up 1 over 1, then do that. Okay, what's my domain here? Good. Negative infinity, positive infinity. What about my range? 0 to infinity. Good. And then the last funny graph before we get into our piecewise is a greatest integer. And you find greatest integer the exact same place we just found absolute value. So I'm going to draw my little sketch of my graph on here. And this 2 actually is in like the B spot of our graph. And the B is like what's being multiplied or divided to the X exactly. We haven't really done very many, if not any transformations of those. So we'll kind of see what happens here. Go to math, go over to NUM. And if you look at mine's number 5, I don't know what yours is. Find INT, and that's integer, and we'll do X divided by 2. Ooh, this will be fun. There's been stair steps too. Okay, now our graphic calculator is very smart. It's not smart enough to realize like it can't pick up its pencil like we can. So we know that there's no like vertical lines or else it wouldn't be a function, but that's the way that they best represent it, okay? Notice, and I don't think I can zoom in on I guess I can zoom in on the graph. Notice how like my line goes from 0 all the way to 2. In a normal greatest integer, it just goes from 0 to 1, and then it jumps up to the next line, and then it goes 1 to 2. This time it's just stretched a little bit. That 2 stretches my graph horizontally. That doesn't affect anything about our domain and range. Our domain is still all real numbers. And if I wanted to draw it, I would just draw like a little longer line. My domain is still all real numbers because the closed and open circles kind of go on top of each other. And then my range is the same as what it was before. It's just all integers. So you can use either the fancy Z symbol, or you can write the list from .. -3, -2, -1, 0, 1, 2, 3, .. All right, that's all of our domain and range from sketching our graphs. This is all these things we've been working on. It's been about reading our graphs, okay? Go ahead and flip your paper over. I think we've got a piecewise to do, and then we're done for today / this section. Go ahead and flip your paper over. Okay. You guys do piecewise functions back in Algebra 2? Yeah, okay. I'm going to treat it like you've never seen it. If I'm moving too fast or too slow, just give me a heads up. Also, once we do these, we'll list any discontinuities based on the graph that's given to us, okay? Very first thing I do is notice where the change happens. And in this case, my change is happening at 0. So I like to make some kind of mark on my graph, either like a very faint line or like a dotted line, so that I can see where should there be a separation. One half of the graph should look one way, the other half of the graph should look somewhere. I don't want to cross my boundaries. Okay. Based on that, now I have to graph X. What is X? What function is that? Identity. What does that look like? Straight line. Where does it go through? 0, 0 goes through the origin, and then it's like going up as we go across the page. One thing you could do is graph the entire line and then just erase the part of the graph that we don't want. You can erase like this because we don't want any of that. Or you can just know what the identity function looks like and just know that it's going to go this way. Finally, one thing you could do is make a t-table, which is probably what your Algebra 2 teachers taught you. Make a chart, and we're going to plug in numbers that are less than and equal to 0. So -3, -2, -1, 0. And when I plug all those numbers in, I get them back out. The identity is itself. So it is -3, -2, -1, 0. So that's what all of those points are along here. I know it's going down because if I didn't have any parameters, the identity function we know just goes through the origin. Like if you drew on your BFF graph, or if you just drew on the board right now, you would know that the identity just goes like that through my paper, right? So if I only want where it's less than or equal to 0, then I don't care about any of this part. So then I can just erase that. So some people like to draw the entire graph and then erase the part that they don't want, and then draw the entire graph and then erase the part where they overlap. But some people, that's too many lines and too much erasing. So that's why I either just draw half or you do the t-table. Now we're going to do our other function, which is our our squaring function. Okay. And now that's where we are less than or greater than 0, excuse me. So when I go greater than 0, I'm looking at this number. And again, you can know that the squaring function goes through 0, 0, and then just use up from there. Or you can plug in 0, 1, 2, etc. to see what points I get from it. So when I square 0, I get 0. When I square 1, I get 1. When I square 2, I get 4. So then you can put those points on there too. Is this a continuous graph, or are there any discontinuities? I think it's continuous, right? We could have drawn it all at one point. We could have drawn a line and then kind of parabola from there. So that I would call this continuous. Let's do the same thing. Let's look at the next one. This one also has our change happening at 0. And we're doing 1 over x for everything less than 0. What graph is that? Reciprocal. So I could just draw my reciprocal down here. Something like that. Or if you forget what your reciprocal is, again, we can make our t-table. And I'll just put in some negatives. So I've got like -3, -2, -1, 0. So that gives me -1/3, -1/2, -1, 0. Oh, 0 over anything doesn't exist, so I wouldn't have a point there. And then I will do my square root function, which again, I should know what that looks like, and that's everything greater than or equal to 0. Where does the square root function start? 0, 0, what does it do? Right? If you forgot, that's okay. We'll plug in 0, we'll plug in 1. Square root of 0 gives me 0. Square root of 1 gives me 1. I don't want to do square root of 2 because that's not a real number, but square root of 4 is 2. So that gives me a couple points to kind of highlight myself. Helps me find a little bit of a shape. We okay with that? Okay. The last one has three parts. So you've got one spot, one spot, one spot. So you got to make sure that you do your best to keep everything in its lane. So let's go look at those. I have a change happening at 0, so I put a mark there. And then I have a change happening at 1, so we'll put a mark there. And I don't care where your 1 is, it just has to go somewhere. I'm going to graph one piece at a time. So the first part we're going to do is -3 minus x, and that's where x is less than or equal to 0. So that's everything on this left side is going to be that graph. Okay? That is what parent graph does that come from? What BFF is that based on? Linear, it's a line. It's a line, if you want to think of it as y equals mx plus b, the m is -1 and the b is -3. So if you wanted to, we could go down to our graph, we could go down to -3, and then we will have to open or close circle at -3, close circle. And then my slope is negative, which means that if I was going to the right, I'd go down 1 over 1 like that. But do I want to go that way? No. So if I go the other way, I can think of it as going up 1 and then left 1. So it will be a negative slope this way, like that. Yes.
I had a question about the square root function. So if it's negative, or like you want to have it flip, wouldn't that be like imaginary numbers? Like if I plug in,
You
like
just won't have a graph there.
just won't have a graph.
It still follows the same rules as the function. So like if it asks me to put it where it's less than or equal to 0, and there's like I can't graph that side of the graph will be empty. Okay. Again, you can make a number line. This one might be a better number, or not number line, excuse me, t-table. This might be an easier t-table to do. I can put in -3, -2, -1, 0, especially if this was more confusing. We just have to make sure that we put in that number in here for my x. So I could do -3 minus 3, which would be 0. I could do -2 minus 3, which would be -1. I could do -1 minus 3, which would be -2, and then I could do -0 minus 3, which is -3. That's what all of these points are anyway. I don't know if I'm explaining that well. Are we okay with that? Okay. Then the next one. This one's a little bit funny because does it have any variables here? There's no variables. There's no x. It just says 1. What kind of graph if there's no variable? How do I graph just 1? Straight line how? Horizontal. 50-50. Yes. So when it's y equals, it's a horizontal line. So we're just going to do a horizontal line through 1. So I'll go up and I'll find 1. And I will put a horizontal line there. It looks like I need open circles on both ends, open, open. And then last but not least is my x squared. My x squared starts at greater than or equal to 1. Does my normal parabola start through the point 1, 0? Where does it really start? Starts through 0 and then kind of parabolas out from there. I still want to think about starting there. I still want to think that it started there. I just am ignoring like this part of the graph. I'm only starting when I get to this point right here. if that is confusing to you, I'm gonna plug in 1, 2, 3 into my x squared equation, because 1 squared is not 0, it's 1. So my first point is actually to close that open circle. Then I'll do 2 squared, which is 4, so I'll jump up to 4, which is about here. So then I will parabola that way. Now I skipped continuity on the last two. Who thinks they know what I would say for discontinuity on either B or C? What should my discontinuity be on one of those?
I know for bottom, non, or sorry, removable.
C is not removable. Removable is when I only take like a point. Did you only take 1 point out? No, we didn't. It's not removable because I didn't just take 1 point out. Is it non-removable where I can't fix it? Okay, do you think you know what it is? I think yep, what do you think? Jump, very good. Why is that one jump? Because it looks like the one that we did, right? The way jump discontinuity works is that I don't just have 1 point that I took, I have a whole part of my graph that I essentially cut from the rest of the graph and I moved it somewhere else. If I wanted to fix it, I could take this and move it back up and I could easily reconnect it to be continuous. Could you easily fix this here? Like use your notability magic to rechange this so that they connect and it's continuous? I don't think so, because you've got this random arrow in the middle of our graph. There's no way that I can let that arrow keep going and connect it. This is what we call non-removable discontinuity.
So removable is when you only take 1 point.
It's like if this was an open circle and then I had put like a point up there. Removable is just when 1 point is moved. Okay, your 1.3 homework is due, and there are 6 piecewise on the back of that homework for you to get extra piecewise practice. I just did all of it. It didn't take me that long, but I think it is helpful if you're struggling with this piecewise function stuff. I promise you there will be a piecewise on your test on Wednesday next week. Also, I did move your calendar to the back. If I'm really good, I'll make a really nice big calendar, but that's not happening today probably. So you can bring your attention to the back. We don't have class tomorrow and I have office hours if you guys need anything.